Hello, I'm Mrs. Boots, and we're going to work with notations in this lesson. Notations are the way we communicate the language of what we are trying to express in mathematics. So with the computer, we use different programming language to accomplish different things. Just like if I'm in one country, I may speak one language. In another country, I'm going to speak another language. Okay, so first, we need to analyze the symbols to understand what our notations are. On your notes, you have the following line graphs. Now, those line graphs can be expressed in two different languages, actually three, right? Because we can use words, we can use inequalities, and we can use intervals. So, in inequalities, for my first graph, notice the arrow points to the right. So my inequality symbol points to the right. This is always true if my variable or my x is on the left. So it would be x, and then this symbol's name is greater than. Greater than symbol. Now notice I didn't put an equal to with that. That's because this dot right here is open, and an open dot means that it's not equal. So for my interval notation, I use parentheses. Now, depending on if it's greater or less as to whether I'm going to use the right parenthesis or left parenthesis. The second line points to the left. So my inequality symbol points to the left. Again, no line underneath because the dot is open. Points to the left. Left is less than. Notice they both start with an L. But it's not equal to. So we're just going to put parentheses there. The next one, wait, this looks like a duplicate. What's that similar to? Similar to the first one. So the third one and the first one look almost identical. The arrow's pointing to the right again, so I know it's a greater than. But there's something different. On number 3, I have a solid dot. That means it's also equal to. So underneath that greater than symbol, I'm going to put a line to indicate that it's also equal to, which means in interval notation, I'm going to use square brackets. On the fourth one, what does that one look like? Looks like the second one, so I know it's a less than. And what's different? Oh, look, it has a solid dot. So this one is also equal to, which means it also has a line underneath. Very beautiful. And that also means it has square brackets. Now we have two tricky ones. The fifth one, notice that the shading is in between two values. That's like it's trapped in between those two values. These are AND statements. The symbol for the AND is, it looks like an arch or an upside down U shape. We don't use it very often because we can do the parentheses and the brackets and accomplish the same thing. But you will see this AND shape in pre-calculus and in statistics. The last one, notice it's on both ends, okay? Both ends is an OR because I can only be at one end or the other. I can't be in both places at once. The OR statement has a U shape, okay? So an AND is sandwiched in between the 2 points, and an OR looks like boat oars coming out the side. Okay, 2 little boat oars that I'm going to come out the side. Okay, so let's use this information, and we're going to write our examples in inequality notation or roster notation, and we're also going to write our examples in interval notation. All right? So, for the inequality notation, all I have to do is look where it's pointed. So I'm going to write my x first, and it's pointed to the left so I'm going to put my less than. It's an open dot, so I don't use the equal to, and then I look at my value. My value is 0. Easy enough. Let's do the inequality on the second one. I look at the arrow. The arrow is pointed to the right. So I put my X, my arrow goes to the right. Greater than, put my value, 3. Oops, missed something. What about my dot? My dot's solid. Solid dot means underline. It's got to be equal to. Example 3. What is this one? This one's my sandwich. That means it's in between. So I'm going to write my X in between two symbols. It's going to be in between two less than symbols. We never use the greater thans. Both boundaries are listed in order. So the smallest one, -1's on the left, biggest one's on the right. So it goes in order. -1 less than X less than 8. Now let's double check the dots. -1 is open, so it doesn't get an equal to. 8 is closed, so it gets an equal to. Easy enough. Example 4. Now we get the fun stuff. I have 2 spots. Remember, this is the or. I can be at one end or the other. So I'm going to write 2 separate inequalities and write the word or in between. So the first one, I'm going to the left. So X is less than -4. Is it equal to? Yes, I have a closed dot. It's equal to. Now I write the word or. Or X is what? Greater than, because this goes to the right at this end, greater than the value of 7. Now, does the 7 get an equal to? No, it does not, because it is an open dot. Now we have a tricky one. Example 5. People think it's tricky, but it's really not. This example is very similar to example 4. You're just not equal to 0. I can get everything to the left and everything to the right. All the numbers in between, except the 0. I could write it just like example 4. Or there's a shortcut. You want to know a shortcut? I do X not equal to 0. That means I can have everything else on that number line, just not 0. Now, example 6 is not in your notes printout, so add it on there. This number line's really different. There's no shading anywhere on it, so I'm not going to have a greater than, and I'm not going to have a less than. All I've got is individual numbers. This is called a set of data. Sets of data have a curly bracket, and it just lists the individual values. Nothing fancy, just the individual values. So whatever numbers have a solid dot, those are the ones we list. Now, let's look at our interval notation. Interval notation, we start learning it in Algebra 2, and you use it in pre-cal and calculus. And the reason we use it is because all of these arrows can be mistaken for other symbols or blend in because we all have messy handwriting. So, we have to identify a few things. First, how far does that arrow go? If you had to pick a number, any number, we could say 1 billion, 1 trillion. Oh, but it's going to the left, so it's going to be negative. But it's going to keep past going 1 trillion. So what we do is we call the left end negative infinity, okay? And the right end is positive infinity. So we have a negative infinity and positive infinity. And if that confuses you, just think about Buzz Lightyear, right? He goes to infinity and beyond. So that's what we're doing. We're going to infinity and beyond, all right? Now, on example 1, we're not going to positive infinity like Buzz. We're doing his enemies. We're going to negative infinity. Not fun, but it happens. So we're going to go negative infinity. We're going to put a parenthesis. Infinities always get parentheses. We never use a bracket with an infinity. You write a comma next. Always write the comma. Then you write your value. Well, It's 0. Now, is the 0 equal to? It's not equal to, it's an open dot, so I put a parenthesis. Easy enough, right? Let's do number 2, interval notation. Where did I start? Going left to right, I start at 3, so I'm going to write my 3. Now, is it equal to 3? Closed dot, it's equal to 3. It gets a square bracket. I always put a comma. Now, how far to the right it goes? It goes to infinity, Buzz Lightyear, and beyond. So we go to positive infinity and beyond. We put a parenthesis because it's always infinity is a parenthesis. Okay, example 3. Remember the sandwich? We're sandwiched. That means no infinities. We don't even have to worry about Buzz Lightyear on this one. We have 2 numbers on the end, so we're going to write our 2 numbers down. -1, 8. Now, parentheses or brackets. Open dot, not equal, parenthesis. Closed dot is equal, square bracket. That's why I said you usually don't see the upside down U, because we can write it just inside parentheses and brackets. And so we see that upside down U later in pre-cal and calculus and in statistics. All right, example 4. Here we got our 2 pieces. That means we're going to have 2 pieces on our interval notation. But don't worry about it. We just do 1 piece at a time. So I'm going to start with the left side. Always start with the left, go to the right, just like you read in a book. We start with negative infinity because it's all the way to the left. Can't go any further than that. We're going to go to the -4. -4 has a closed dot. Closed dot means a bracket. Now, remember that OR symbol? It's the U. Think of it as a tunnel. I'm going to tunnel underneath all of the values between -4 and the next on my graph, which is 7. So I tunnel over to my 7. Now, is it equal to 7? No. So it's going to get a parenthesis. 7 gets the parenthesis, and then it keeps going to the right, all the way to the right. So we have a positive infinity. Wonderful, wonderful. Okay, so negative infinity, this is the one that confuses everyone, to -4. U shape, remember we're tunneling underneath. 7 to positive infinity. Okay, the cool part is example 5 and example 4 look identical, almost, for my interval notation. I still start at negative infinity. I go all the way to 0, but 0 is not equal, so we get a parenthesis. We do our tunnel, go down underneath, but we're going to come up on the other side just a little smidge past 0. So we put a parenthesis to say, no, it's not equal to 0 on either side. We don't want that 0. I only want everything to the left and everything to the right. Remember, infinities, positive or negative, always get parentheses. Last one is number 6. And this is why you typically don't cover this. Guess what? There is no interval notation for that. You can't do it. So we simply leave it as a set of numbers. We don't do an interval notation, and that concludes our notations and how we use them. Now, for Algebra 2, we are going to be using these interval notation symbols. So everything that we do, domain, range, all of those, we're going to have the parentheses and brackets. So make sure that you understand it. Thank you very much, and you have a wonderful